Welcome to Hacking AI channel. We're all about showing deep tutorials about AI. This is the second installment on DSPy. If you're not sure what this thing about, you can watch the first episode. The link is in the description. Here's a quick refresher. DSPy is a ray of sunshine in a gloomy afternoon of prompt engineering. This framework helps you optimize and evaluate your prompts by leveraging ground truth samples. Reminds you of something? Yes, supervised learning. I'm hoping that this tutorial will be the most comprehensive so far, and if you find anything missing, please tell me on the comments below. We will also peek under the hood of the implementation of the library, because that's what Hacking AI is all about, knowing from the bottom up. Without further ado, let's jump to the code. Here's the content of the Jupyter notebook. We're going to define classifiers, datasets, and a hidden gem, DSPy.Examples. This detail is missing from most of the tutorials online, and that's one of the reasons that I've created this one. We're going to define optimizers, evaluation, and then run the actual evaluation with different optimizers, and eventually save the prompts. Let's go. Let's start with defining the classifier. So this classifier should be used in the context of customer service interactions. Given a conversation, want to classify what type of conversation is it? Is it a cancel subscription one? Is the user requesting a refund? And we want to do it by inputting a conversation and a set of predefined labels. But it is dynamic, we can change the labels as we go. So here are the inputs, this is the output. These are the settings of the type of LLM I'm choosing, GPT-4o Mini. And I'm slapping chain of thought on top of it. This is how easy it is to just add chain of thought to your prompt. Atis dataset has airline company customer requests. Things like, I've missed my flight, how can I get a new one, and so forth. I'm always using some sort of open data set whenever I validate frameworks or different methodologies. Why? Because it has already a lot of ground truth. It's already labeled, so I can use it somewhat safely. This is how one row looks like. I want to fly from Boston at yada yada yada. And the class is flight. It's called intent in this context. So I need to prepare all of the labels because that's an input to my classifier. So I concat them with the delimiter of percentage because that's what I found out work best. Here's an example of a prediction and the output. So this returns an object, prediction, and it has a rationale and also an answer. Great. Now we're going to define DSPy.Examples. This is part of the reason that I've created this video. Most tutorials miss this part, and it's crucial because essentially if you want to optimize, we need examples for. So DSPy lets you build with their object, defining whatever you need. So in this instance, I'm adding a custom message and intent labels as input and an answer column because at the end we need to optimize against something. So we're signifying to DSPy, look, check whether the prediction is matching this answer. And without adding with inputs method, it just won't work. I've tried, believe me. And these minute details are not relevant, or you just can't know them until you try. So I'm hoping that this will accelerate the time of usage for you. How am I doing this? I've defined this method, and now I'm creating train examples, test examples, and dev examples. Now let's go over the optimizers. Optimizers in DSPy can change three things: prompt instructions, the few shot examples for in-context learning, or changing the LLM weights directly. Changing the weights directly is out of scope for this session, so we'll focus on prompt changing and few shot examples changing. Each optimizer does it a little bit differently, so we'll go over 3 different examples. Here's the first optimizer, LabelledFewShot. This is the simplest optimizer. Given examples, we sample k from them and initialize the examples for the few shot in the prompt. In DSPy, these are called demos. There is no actual optimization happening. You can look at the implementation. I've added a snippet from it. You can see that we only sample some samples from the dataset, and that's it. No optimization. What's great about it is that you don't need to think about how exactly to add it to the prompt. Basically, the framework knows how to add those examples for you. How can you see the resulting prompt? If you're like me and eager to see the output, you can inspect it easily. Here's the task definition. Here is the task format. And here are the examples that have been selected randomly. Actually, there's also the output here. And you can see the reasoning part and the answer. Our next optimizer is the FewShot Bootstrap. It synthesizes additional examples. It is useful when you are low on labeled data. But you only keep the synthetic examples that the model was able to predict correctly. Even though it can be a risky procedure because the synthesized data can be misleading and thus lower the quality. We'll see an example of that during the evaluation phase. Now let's look at the code of the library. I've added a small portion. You can see that not only we're using the raw demos, but we're also adding the augmented ones. This is the first optimizer that has a significant evaluation phase. Under the hood, it is running BootstrapFewShot in a loop, depending on the number of programs you input. Each time we'll sample and synthesize different examples through using a different random seed. After we create the examples, we evaluate the prompt and keep the one that led to the highest result. You can see out of the evaluation that I run here under the compilation that we got a result of 89. And here's the implementation in the source. No surprises here. We're randomizing the seed each time in a loop and then evaluate the code. Let's start the evaluation process. In order to understand it better, let's first evaluate only one example. Here I'm choosing a metric, answer exact match. I'm using DSPy.Example again that I predefined and running it with input methods. Without it, it won't work. You can see that so far I have 100% match score because the intent was flight and the model predicted flight. Next, we'll evaluate different models and optimizers on a test set. We first need to define the bulk evaluation by passing the evaluation examples. I also added number of threads in order to expedite the calculation. And here are the results of the evaluation, and they are quite surprising. The classifier with chain of thought without any examples in the prompt got a whopping 88%. Comparing it with the FewShot chain of thought that got only 78%. How can it be? Atis dataset is a very imbalanced one. Most of the examples are flight class. I haven't done a thorough error analysis, but that would be my first suspicion, that the FewShot examples were picked from the other classes. Let's move on to the other optimizers. The BootstrapFewShot got 88, which is very similar to the chain of thought one. But our clear winner is the BootstrapRandomSearch, which got 95% of exact matches. I remind you that it was optimized through a random search on the seeds to find the best examples in the training set. And it was really reflected during the evaluation of the test set. Here's the final code snippet. Here is how we save and load the prompts behind the optimizers and the models. This is much better than the prompt being hard-coded into the code, right? So far for the code. To summarize, I have defined the classifier and different optimizers. To simplify evaluation, I have focused on an open dataset with customer service interactions. You can see all of the code in a repository linked in the description. I hope that DSPy prompt programming is no longer a mystery for you. If you want to see more content like this, you can subscribe to this channel or find me on various platforms. Have a good one.